Hi everyone, like she said, my name is Kelley. I'll be talking about machine learning forecasting. So just a little bit about myself. So I've been at Tableau for the past 2 years working on our global sales strategy team. I have my PhD from the University of Washington where I studied earthquakes. And I am a proud dog mom, this is my dog Gus, and I coach Ultimate Frisbee at the University of Washington. So that's just a little bit about myself. So everybody wants their business to be as predictable as possible, especially when you talk to your business leaders. They want to be able to understand what's happening, how they can drive their business. That's not as easy as it sounds. There are a lot of factors that go into why your business isn't predictable. We've got major macroeconomic swings that are driving, for us, software sales. You also have different business segments and regions doing their business differently, so there's not a lot of insight or consistency across the business. And also, you might just not have the trust of your stakeholders. They may not trust machine learning, they might not know how to use it, and so you might have a predictable business, but we don't have insight into that. So in this talk I'm trying, you'll take away a couple things. The goal is to understand how you could identify what's a good problem space for a forecasting model, how you would choose that kind of model, and then also some common pitfalls that I fell into when I was working on my sales forecasting issue and how to solve that. And then the last thing I'll talk about, but it's probably the most important even though it's last, is enablement and trust building with your stakeholders. It does not matter how great a model that you built if no one uses it. So how do you get stakeholders to use your model? So step one in the process is identifying a good problem space for a forecasting model. We're talking about specifically here time series forecasting, just so we're all on the same page. You're looking for areas of your business that have cyclical behavior. Humans are very good at identifying patterns, so if you can't see a pattern in the data, it's probably not a good space for a data science model. And I'll give the example here of software sales. Sales leaders want to be able to forecast their business and say, this is how much business we're going to do this quarter. We can break our business up into two major buckets. The first is what we call create and close deals. This just means they open and close in the same quarter. Some things about our create and close business, the deals are smaller in dollar size, but higher in volume, so there's a lot of data points. It's what we call high velocity, so it open and close in the same quarter, and all of it's really tied to time and the quarter cycle, so it's really driven by our fiscal calendar. The other side is our large deals. These are our multi-million-dollar deals. They're smaller in volume, so there's not as many of them, but they're higher in dollar size. Obviously, they're multi-million-dollar deals. They are what we call low velocity, meaning they can take multiple quarters or even years to come to fruition, which means they're really not tied to the fiscal calendar or time at all. And I've kind of set you up in how I've described the two spaces of what makes a good problem space for a forecasting model, which is our create and close deals. Really tied to time, a lot of data points, and still very impactful on our business. So then your next step is selecting a model. There are a lot of questions that go into how you're going to select what is the best model. And the first one is probably how you start every data science model. How much data do you actually have? So what's the cadence that you're getting at? How many data points do you have? If you have 2 years of data, but you only have it every quarter, you have 8 data points. You are not going to create a complex data science model off 8 data points. If you have hourly data for the past 2 years, you have probably more data points than you want to deal with, and you have a different problem. But that's the first question. How much data do I actually have? How much of it is quality data? The next question you want to ask yourself is how important is explainability versus performance? And I'm sure you'll ask any business leader and they're like, performance, performance, performance. But that's not actually how they're going to use the model. So for sales forecasting, they want to know the number on the dot They really want to be able to tell their boss, this is exactly how much business I'm going to close. They don't really care how you got that number. But you might have something like customer churn or support case volume, and you might want to know, how can I turn the knobs in my model to get a different answer? And so then explainability is more important than trying to nail exactly what the number is. So that's going to inform what kind of model you choose. And then the last thing is, do you need to incorporate other variables besides time? Most time series forecasting models are going to have the one variable you're trying to predict and time, and maybe some like time adjacent features. If you're looking to add in other variables, you're going to dive on the spectrum into more complex models. And this is a space, again, where you need to advocate with your business users and stakeholders. Okay, do you really need that other feature? So for example, our sales forecasting model is going to predict our sales. And I got asked, can we incorporate US government budget on tech spending into the model? And the answer is no, because that's insanely complicated, does not exist as a data set. And the answer was also to go back to them and not just say no, but say no, and this is how you use the model. That's something where a human can apply their intuition to the model result. So it's not just my number is the capital T truth, but you're a sales leader, you know your business, apply human intuition into this problem. Okay, so I've also put in a plot of ranging from the most simple to the most complex of different, pretty common time series models. The simplest, could you fit it with a line? That might solve your problem. Great, lucky for you. In between there, all of these I've boxed as univariate, meaning the one variable. You have an ARIMA model. A really common other model is Facebook profit, which is sort of seasonal decomposition. I won't go into that one. On the very most complex side is like a deep neural network. I also won't go into that. And then a state space model, which I'll talk about more. So going back to the problem space that I set up, I'm talking about software sales. We had 2 years of data at the daily level. So we could go with a greedier, more complex model. Our performance was much more important than explainability, as I said. And we were also trying to calculate multiple time series at once. And I'll go into how that played out later in the talk. So the simplest model is not going to work for us, but we probably don't need the most complex model. So going with this state space model. So what is a state space model? And now that I've selected that model, how do I connect the pipe? The state space model, like I said, it's pretty greedy. It does need a lot of data. It's moderately complex, and it can take in the multiple time series. It can also take in non-time features. And so we were able to incorporate what quarter is it, day of quarter, time adjacent, but not time exactly. Okay. So an example I like to use for a state space model is the GPS in your car. What this model is trying to do is it has some understanding of the state of your system. It's going to say, I'm going to make a prediction or a guess at where we're going to be in this example when you go through the tunnel. Here's where you're going to be when you come out based on everything I know about the car. If you come out of that tunnel, it's going to measure where you actually are and say, oops, gotta like adjust my estimate of the state of your system. And it's constantly trying to understand the underlying distribution of your data. So it's really dynamic. It's a little bit more sensitive to more recent changes in the system, which is great for software sales because how we sold software 2 years ago, not the same macroeconomics as right now. I also just want to highlight the pipe that I connected because I feel like this often gets skipped over in data science and is an important step. So we pull all of our data out of our Snowflake database. GluonTS is the package that I use. It's developed by Amazon. It's a wrapper that It contains pretty much every time series model you might be interested in. It wraps up Facebook profit, so it's a great starting point if you want to figure out one package and try a bunch of models. And then all of this is packaged up in a Docker container, and it lives up on AWS. And there's a system that we just found like 2 weeks ago called Fargate that can automatically run that Docker container and automate our runs of our model. And then it all gets pushed into Tableau so that people can use and understand the data. So some pitfalls that I ran into is time series models are very sensitive to noise and to strong outliers. And for our business, there was a really strong weekend signal. We're not selling any software on the weekends. We're selling millions of dollars of software on the weekdays. And the time series model was like, cool, and only learned the weekday signal. So the solution that I found to that as part of the pre-processing was to go and smooth that with a 7-day moving average. And that helped improve my model fit. The second bump is that sometimes that outlier is not an outlier. So at the end of the quarter, that spike, you might be like, oh, that's an outlier, smooth it out. No, that's really important business and a good chunk of our business. So how do I get the model to say, like, that's not an outlier, that's real data? And this is where we had to go with a slightly more complex model, where I was able to add in a feature that's basically a flag that says, it's the end of the quarter. And now the model's like, okay, I'm going to treat this chunk of time different than I treat the rest of time. And that led to a really good fit. Then you have to define success and your metrics. So I'm not going to go into SMAPE, but synthetic mean absolute percent, or symmetric, I always call it synthetic. Symmetric mean absolute percent error is the metric. It's a pretty common forecasting metric. You can't do normal cross-validation with a time series, so you kind of do this running buckets of test and train, or train and test. So you can just see forward step in time, how did I do? This is really convenient with quarters. I just went by quarter. I think this was the most unique part of our forecast. So what we were forecasting was hierarchical. So we're going down the sales ladder. And there's sort of two mentalities that you can do. You can predict from the top and smear all of that prediction down, but you have to be really confident in how it's distributed down your hierarchy. And that might change over time. Instead, my approach was to go from the bottom up, and I went as deep in the tree as I could go and still get a good signal, and predicted basically all of the bottom nodes of the tree. So our deep down in our sales hierarchy, predicted those individuals, and then all of that aggregates up to our final number. So I never have to predetermine how our sales are distributed across different regions or segments. I just predicted the bottom and go up, which I found to be much more successful. And then the last step, I feel bad this is the last, it gets last 30 seconds of it, but is stakeholder buy-in. So I worked really closely with our analyst team, and they are wizards with Tableau. I truly don't know how they make the dashboards that they do, and I'm a little sad that I can't show the true dashboard because it has all of our sales numbers, and I did not say okay to that. But we have this dashboard that allows sales leaders to basically ask questions of the data and ask everything that you might want to ask. How did we perform last year? How did the model perform for the last 2 years? What am I expecting in my business for the coming quarter? How does that break down amongst my direct reports? And they can click and interact with all of that data and ask the questions. And this is how they built confidence in the model. They can go and be like, why is my number weird? And I can go and say, look at the dashboard this way. This is how your data works and how the model works. So you have hopefully learned how to identify what's a good space for you to use this kind of time series forecasting, how to pick a good model, and try and navigate that simple to complex range. I've talked about both smoothing of the data and also trying to use business knowledge to understand what is an outlier versus real data. And then also talked about sales enablement, or not sales enablement, data science enablement, and how you can get your stakeholders bought into your machine learning models so they actually use it. Thank you.
Awesome. Thank you for the talk, Kelley. Now we'll open up for the questions. We have 5 minutes. Go.
Hi, great talk, thank you. I was wondering, one of the challenges we face with forecasting models is they break down in case of black swan events, like a global pandemic. And throwing away a year's worth of data as outliers is not an option because now you're dealing with a new normal. That's the baseline. So wondering if you had that challenge.
Yes, our challenge was slightly different in that, similar, but we had a total shift in our Tableau as we merged in with Salesforce. We totally shifted our fiscal calendar from the calendar to the fiscal calendar. And so there was a little bit of the way the time series acted was different. This is why I went with a slightly more flexible model. That state space model is more sensitive to more recent performance, and so it's going to be more responsive. And sometimes that's a pro and a con. Like some people want their business to be more stable. The other thing is like thinking the balance between overcorrecting. I think a lot of forecasting models have overcorrected for COVID opening, closing, where we are now. So yeah, you can also kind of combat that with both how you like pre-process the data and also what kind of model you select.
I enjoyed the talk. One question I had was your bottom-up approach. You mentioned how you predicted each of your nodes separately and then aggregated up. So did you build different models for each of those different prediction time series nodes?
This was also why we went with the state space model, but it predicts, so we have 164 nodes at the bottom for Tableau alone, and it predicts them all simultaneously. So because the business is related but unique, it has the ability to do all of those time series at once. We did extend this model out to the entire Salesforce business, not just Tableau. And in that, I had to go and look at the data at the beginning and group businesses by similarity. So this is very niche, but public sector spending is totally different than any other tech spending. And so they just had to be predicted. They get their own boutique, bespoke model because their cadence is really different because it's driven by government budgets. So that's the only spot where I predicted them separately, but I was able to predict all of those nodes simultaneously and then aggregate up.
We have time for one more.
Back here.
Thank you for your talk. We have used state space model, and most of the case studies that I've seen use either RMA or state space. Did you consider using deep learning? Like I've not seen that very often in the time series forecasting. So what's your take on that?
I didn't. Well, so the way it's implemented has like a slight flavor of deep learning in that it uses a neural network to estimate the state's variable, or like this implementation of it. It's a deep state space model, so it's using neural networks to estimate the state vector, not to get too niche into it, but to estimate the state vector at each step, so it's a little combo. And the reason why I liked that is the true deep learning, it feels a little too black box for me. Of like the state space model, I could still explain to a business leader in like real terms why it was doing what it was doing. And it gave me more flexibility of adding in things like quarter, day of quarter, is at the end of quarter, all of those features. So I didn't go full deep learning, I just went like a sprinkle of deep learning.
All right, thank you for the great presentation, Kelley.